7-4 day 2 pre-lesson. It's the last lesson of unit 7. Here we go. So you can see I've got the sine wave or the sine function graph. Here it is. We know A is 1 from right here. We know B is 1 from right there. So this is the simplest one you can have. We're going to build on that. What today's lesson is about is this word frequency, which is found from the period. So today, if you understand period, this shouldn't be whoa, it should just be a different way of kind of looking at it. It's a different word that gets attached to sine wave, cosine wave. Here we go. Amplitude, absolute value A, absolute value 1, which is 1. Period, we already know the period of regular old sine is 2 pi, but now let's use the formula. 2 pi over the absolute value B, which is 2 pi over 1, which is just 2 pi. So again, you can go by the picture, or you can go by the formula, whatever. Here comes this new word, frequency. Now, I'm giving you this as a formula, then we're going to talk about it. It's 1 over the period. So the period is 2 pi, so it's 1 over 2 pi. So we would say that the frequency of this, again, it's connected to period, but it's talked about slightly different. It goes through one cycle every 2 pi. So it takes 2 pi for it to complete a cycle. So we're going to stick with this as our always. There's different ways to kind of talk about frequency, but let's simplify it. It takes 2 pi to go through one cycle. So I like to look at it from bottom up, actually, okay? Which is a little different when you're looking at a fraction. A little more challenging problem. The challenging part, I don't really think is the new word frequency. It's just this, okay? You guys, this is semi-new, but let's tackle it. So first of all, let's talk about the amplitude. So we got a different A. So my amplitude is going to be the absolute value of 5, which is just 5. So instead of it being 1, we're going to go 1, 2, 3, 4, 5. And this point is just going to go right up here. It goes up and comes down. So you can see the amplitude, vertical stretch, factor of 5. By the way, every now and then a student adds 5 to this, and then they end up at 6. It's 5 times whatever the amplitude was. So 5 times 1 is 5. And then, if this is negative 1, I'm just going to draw something down here and not worry about the accuracy. And then that's going to come here and here. All right. Are we done? Does this have anything to do with the frequency? No. Okay, because we haven't dealt with B yet. So we know that we find frequency from period because the formula is 1 over the period. So we got to find the period first. So what is B? B is 1/2, making this 1/2. And then we flip and multiply. Flip this, multiply by that, we're going to get 4 pi. So now, if I draw it, which by the way, this problem doesn't even ask you to graph it, but I'm throwing this in for free. This graph has to go through one cycle now in 4 pi. See, this is 2 pi because 180 is 1 pi. So if this is 2 pi, we double it, that'd be 4 pi. That's what 7/20 is. So I have to draw this same drawing in this amount of space. So it's getting horizontally stretched. It was vertically stretched. Now we're going to horizontally stretch it. So take a snapshot. The halfway point is where it goes up to 5 and down to 0. So the new halfway point is right here. So I'm going to have this point right here halfway. So that would move right here. So that's going to go up and down. And then, so it took 360 for it to go up and down. Now we got to take another 360 for it to go down and up. So the halfway point would be here. So this would go down and up. So there's the new graph of this. You could type it in. You know, the problem with decimals here is these are going to be different, so it might not look similar, but it is. Okay? So, what is the period? The period is 4 pi. So the frequency is it goes through one cycle every 4 pi, or it takes 4 pi in order for it to go through one cycle, 1 over the period. A couple practice problems for you. So a lot of times the book is just going to give you this sinusoid or cosine function and ask you for these 3 things, and they're not going to worry about you graphing it. But I am, so I'm going to force you guys to graph a few, so be prepared for that. That's why I'm showing you a little extra. So let's just do what they want and use the formula. So the amplitude is the absolute value of a half, which is a half. So we now know that it's not going to go up to 1 or down to -1, it's only going to go up to a half. This is our period here. That's our letter B. That's going to affect this. So it's 2 pi, I don't leave myself much space, over B. It's the absolute value of B. But in this case, it's positive, so it doesn't matter. So 2 pi over 2 is pi. And then the frequency is just 1 over our period. So it's going to go through one cycle every pi. Or it takes pi to go through one cycle. So let's take a look at it. So your author of your book is pleased as punch. You know how to find amplitude, period, frequency, but let's take a little snapshot, practice graphing one more time. So now our parent function is cosine, so we have to know what y equals cosine of x looks like. So it starts here, just does, and it goes from 1 to 0, 0 to -1, -1 back to 0, back to 1. There it is. It's your tulip or what have you. All right, now we got to make our adjustments. One adjustment at a time, a half. So that is going to be vertically compressed to here. If you compress 0, it's just 0. What's 1/2 times 0? 0. So it goes here to here. This spot goes here. That goes back to here. That goes a half. So it was vertically compressed. That's what A, being a fraction less than 1, does. What does this do? Well, now our period is going to be pi. Remember, right now, it's 2 pi. You can just look at it. So now we got to somehow bring this in. So I like to think of this as my wall, and I'm going to bring my wall in halfway. So because original period was 2 pi, and now it's pi, I know this is half. So I'm going to come in halfway, and there's my new wall. And what I have to do is draw the red tulip in this space. Now look what happens. It goes down through 0, halfway, kind of looks like this, and then it gets down to -1/2. So this has to come here. In this little half of a window, I got to recreate this. So that's going to come like this and like that. And then from this half of the window, it should go right here. This little half of the window, it needs to copy this. So there's my halfway point. It's going to come up here and right there. So that's the red tulip smushed horizontally by a half. So there's the drawing, and there's your answers. So get used to that. Might be challenging at first. Last one. So take a little snapshot of this one. When we have pi over 4 right here, instead of 2 or 1/2, that makes our ability to draw it way less effective, and this is where we're going to just rely on technology, Desmos, to kind of help us out. So we could do it, but I would bore you to death. Just go to Desmos if you're curious about what it looks like. But on this one, we're just going to stuff it in here. Absolute value of 4 is 4. Period is 2 pi over the absolute value of B, but because it's positive, it's just pi over 4. Now, what do you have? What do you do when you have a fraction in the bottom of the denominator? The top stays, and then you times it by the reciprocal. So that'd be 4 over pi. Now, these would cancel. You get this weird number 8. Now, I didn't explain this in an example earlier, but this is in terms of radians. And if I was to draw you a graph, you know, we've been doing 90 and then 180, but really, this is pi over 2, this is pi, and that's all in terms of radians. We get 8 radians. Remember what 1 radian is. It's approximately 60 degrees. So this is saying 8 radians, so that's saying approximately 480. Approximate. But it's, again, that's why we're not going to mess around with it, because it's really kind of something we're not focusing on right now. But 1 over the period, well, the period is 8, so it takes 1 over 8 radians, if you want to really be specific about the answers here. So there you go. That's it. Good luck on your homework, guys.